All right, hopefully this video will make you get a better grasp on John Conway's rules. We'll start by explaining them once more before I show the 9 examples I have. So, each cell with no neighbors or one neighbor dies as if by solitude. We can see this occurring right here. This cell has one neighbor and it ends up dying in the next generation because of that. Each cell with 4 or more neighbors dies as if by overpopulation. You can see this happening. This square has 5 neighbors surrounding it and does not live on to see the next generation. Thirdly, each cell with 2 or 3 neighbors survives. So we can see this happening right here. This cell will live on to the next generation because it has 1 and 2 neighbors. And finally, for a space that is empty or populated, or unpopulated, sorry, each cell with 3 neighbors becomes populated. We will see this occurring right here. This cell has 3 neighbors and it reincarnates right here. So, moving on, we will move on to these 9 examples. These 3 examples will showcase how this square, and this square will all live on to the next generation because it is surrounded by 2 or 3 neighbors. See that? And then we are left with 2 patterns of still life, which live on forever. And next, we have these 3 examples, which showcase the resurrecting of the squares. We will see in this unpopulated cell area, in these 2 unpopulated cell areas, and this unpopulated cell area, a square will be resurrected in its place because it is surrounded by exactly 3 squares. There we have it, and there we go. And then we are left with the pattern of the oscillator, which goes on forever. And finally, we have this example. These 2 examples right here specifically are examples of undercrowding. This whole cluster of cells is an example of overcrowding. We'll see that this cell dies out, this cell dies out, and this cell dies out. And there we have it. And then this cell will only live to see 4 generations. I hope that helps you explain it a bit more. If you have any questions, sure, we can answer them.